This video is going to explain the second of Kirchoff's two rules for circuit analysis. Sometimes it's referred to as the loop rule. Before Kirchoff's second rule, before we get into it, a little bit of background, make sure everyone understands what we're talking about. Voltage is proportional to our potential energy, because it's defined as energy per coulomb of charge. According to the second law of thermodynamics, energy always flows from high potential energy to low potential energy. The positive side of the battery has more potential energy than the negative side, and current is defined as the flow of charge from high energy to low energy. In case you haven't figured it out, the second rule is going to be about energy, conservation of energy to be exact. Now if I look at a battery, this is my symbol for the battery. The vertical lines, the long vertical line is the positive side of the battery, the short vertical line is the negative side of the battery. In terms of energy, the negative side is a lower energy than the positive side. When we define current as the flow of energy from high energy to low energy. So current is represented by the letter I, capital I, and it's a flow of energy, which happens to correspond to the flow of positive charge in order to make this work. And finally, Ohm's law, delta V is equal to IR. Now when we look at a circuit, we'll have a circuit like this, and what we're going to do is we need to organize this on paper. So every element that's in my circuit is going to use up some amount of the voltage. That's all my little delta V's that I have popping up here. And in order to organize my work, what I'm going to do is I'm going to have to go around my circuit in a loop. So I'm going to start at the star. The star can be anywhere in the circuit. I just pick the upper right-hand corner kind of randomly. And I'm going around and go clockwise direction. I could go counterclockwise. Again, I call it my arbitrary direction of analysis because it doesn't matter which direction you pick. And this is just to organize my work on paper. So by using this, I'll use all my little delta V's, all my little voltage drops and rises in the order they appear in my circuit. So I'll go through V1, V2, V3, V4, V5, 6, 7, and V9, all in that order. And that way just keeps my work organized so I don't accidentally count something twice. Now the rule. The rule says the sum of the voltage changes in a circuit loop equals 0. Since voltage represents energy, this is really a conservation of energy rule. When analyzing it, there are two things to consider. First is the direction of the currents between the junctions, and the other is the directions I'm going to organize my work. Organizing my work has nothing to do with physics, nothing to do with math, it's just organization so you don't count something twice. So here's a piece of a circuit. 2 4-ohm resistors and a junction with a little branch going upwards. I'm going to label 2 currents. So I have I1 coming from the left, I2 coming from the right, and they're going to go up the middle. Now I'm not going to worry about what's going up the middle, I'm just looking at the 2 4-ohm resistors. When I analyze this, I'm going to organize my work going from left to right as I move across my resistors. And you'll see more of this in the example problem. So when I look at this, current flows from high energy to low energy. On the left-hand side is the high energy, that's where the current comes from, that's where I1 comes from. And it goes to the right, which is the lower energy. So energy flows from left to right. In order to go from high energy to low energy, I have to remove voltage across that resistor mathematically. So I write that as negative I1 4 ohms. I1 instead of I2 because I1 goes through that 4-ohm resistor. On the other side, if I look at it, going from left to right, I have the junction, lower energy, the resistor, and higher energy. Remember, current flows from high energy to low energy. So in this case, I2, the high energy is on the right, the low energy is on the left. So when I travel across it in my analysis direction, I go from left to right or from low energy to high energy. To go from low to high, I have to add voltage. So delta V is equal to positive I2 times 4 ohms. I2 because I2 is going through that 4-ohm resistor. So when I'm going with the direction of the current, analyzing with the direction, I subtract voltage, and when I'm going the opposite direction, voltage is gained, so I add it mathematically. The batteries, you do not pay attention to the current, you only look at the positive and negative signs. So this is my direction of analysis going across it. Negative is lower than positive in terms of energy. So as I go across the first battery, I go from low to high, that means I'm going to have to mathematically add my voltage in my loop equation. The second battery, I go from high, which is positive, to low, which is negative. So I go from high to low, I remove energy. So the battery's working against the circuit in this case. So I'm going to remove some energy out of all that. So when I'm doing my analysis, that's what I'm going to put in there, positive and negative voltage. Remember, ignore the current for batteries, pay attention to the current when you're doing the resistors. Add the voltage when you're going from negative to positive, subtract when you go from positive to negative because you're going down in energy.